Welcome back, guys, to Goze Science Academy. In this particular video, I'm going to be talking about laws of indices, or you say the rule of indices, as the case may be. I'm going to be stating all the rules of indices in mathematics. This is a very important concept in mathematics that is applicable everywhere, especially in science-related subjects such as physics and chemistry. You always come to things that has to do with these laws. So let's jump right into these laws and see how it actually looks like. So we are looking at rules of indices, or I say laws of indices. So this is what we are looking at. I promised to make a video on this due to the last one. So the first law of indices is called the multiplication law. Most textbooks call it the multiplication law or the product law. So the first law of indices is called the what? Multiplication law. So if I have a number a raised to power n multiplied by that same number raised to power another base, another exponent, say n, is equal to a to the power of m plus n. That is it. If I have a number, say a, if those numbers, the two numbers I have are of same base and different exponents, all I have to do is to retain the base and multiply and add the power. For example, if I have, say, y raised to power 6 multiplied by y raised to power 5, this is equal to saying y raised to power 6 plus 5, which is equal to y raised to power 11. If I also have, say, a raised to power 7 multiplied by a raised to power 2, it's the same thing as retaining the base a and then add the power 7 plus 2, which is equal to what? A raised to power what? 9. So that is what the multiplication rule is stating. Retain the base and add the power. Retain the base and add the power. As simple as that. Let's go to the next one. The next rule, rule number 2, is called the division rule. So it states if I have a raised to power m divided by a raised to power n is equal to a raised to power m multiply a raised to power m minus n. So if I have a raised to power m divided by a raised to power n, all I have to do is to retain the base and subtract the power. So when it comes to multiplication, you subtract the power, retain the base. But when it comes to multiplication, you add the power and retain the base. That is just the difference. So, example, if I have, say, x raised to power 8 divided by x raised to power 7, that is all the same thing as saying x raised to power 8 divided by x raised to power 7. That is the same. So all we have to do is to subtract the power, retain the base x, and then say 8 minus what? 7. Then that will give us x raised to power 1, which is just x. If I have y raised to power 2 divided by y raised to power 1, or y raised to power 2, same thing. What I have to do is to say y raised to power 2 minus 2, which is equal to y raised to power 0, and any number raised to power 0 is equal to 1. So that is just it. So all we have to do is to retain the base and what? Subtract the power. So that's it. Let's go to the next law. Law number 3 is called the product law. If I have a raised to power m multiplied by n, again, this is equal to a raised to power m multiplied by n. So when you have a raised to power a base, or raised to power another, a raised to power an exponent, raised to another exponent, raised to another number, So I have two exponents. This is a number having another exponent. It has an exponent and then has another exponent. All I have to do is to multiply the exponent and retain the base. So that will just give me a raised to the power what? Mn. So example, if I have, let me say a raised to the power 2 or raised to the power 4, this is the same thing as saying a raised to the power 2 times 4, which is equal to a raised to the power 8. So that's it. If I have x raised to the power 7 multiplied by 2, that is the same thing as saying x raised to the power 7 times 2, which is equal to x raised to the power 14. So that's just it. Rule number 4. Rule number 4, if I have a number raised to the power 0, as stated before, it's just the same thing that is equal to 1. Why? Because a raised to the power m divided by a raised to the power n is equal to a raised to the power m minus n. We know this. And it is the same thing as saying a raised to the power m divided by a raised to the power what? N. And then if n is equal to m, this is saying a raised to the power m, in place of n I put in n. So this is equal to what? A raised to the power 0. And a raised to the power m divided by a raised to the power m, because this is relating to this, is equal to what? 1. So this can cancel off and give me what? 1. So we conclude that what? A raised to the power 0 is equal to 1. Example, x raised to the power 0 is equal to 1. Y raised to the power 0 is equal to 1. A raised to the power 0 is equal to 1. Any number 100, even if it's a constant, raised to the power 0 is equal to 1. So that is just it. Rule number 5. So rule number 5, a raised to the power minus m is equal to 1 divided by a raised to the power m. That is it. A raised to the power minus m is taking the reciprocal, that is 1 divided by what? A raised to the power m. So I don't need to prove this. I don't want to show this to avoid confusion. So let us just take an example. If I have x to the power minus 7, it's the same thing as saying 1 divided by x to the power 7. So taking out the negative sign at the exponent is just taking the what? Reciprocal. If I have a to the power minus 8, it's the same thing as 1 divided by a to the power 8. So that is just it. Number 6. Rule number 6 say a to the power 1 divided by m is equal to m root of a. This is m root of a. So that is just it. I don't need to prove this. So a to the power 1 to m, that is the power is a quotient, is the m root of what? A. This implies that if I say a to the power 2 divided by m, this is the same thing as saying this is what? This is the m root of a raised to the power 2. So this is the m, for this one, this is the m root of a to the power 1, and a to the power 1 is still 1. So this is the power. The numerator of the exponent of the quotient, the exponent that is a quotient, is the power. We take it as the power. So this leads us to saying that a raised to the power n divided by m is equal to what? M root of a to the power n. Let's see examples. If I have a to the power 1 is to 3, this is what? The cube root of a. If I have a to the power 1 is to 4, this is what? The fourth root of a. If I have a to the power 2 is to 3, this is what? The cube root of a is to 2. This is because a to the power, this is the same thing as saying a to the power 2, 1 is to 3 multiplied by 2, which is equal to cube root of what? A to 2. So another example, another way you can see, if I say, so you say I have x to the power 3 is to 4. this is the same thing as saying x raised to the power 1 is to 4 times 7. And this is the same thing as saying x raised to power 7 is to 4. Yes, so this is the same thing as saying the fourth root of x to the power of what? 7.